Hi, everyone. Thanks for jumping on with us today. My name is Lauren Conaway. I am the marketing manager at Principal LED. And we're excited to have you guys on the call today. Jeff will be taking over here in just a second to walk you guys through the production edition of LED Wizard 8. And as always, please remember, if you have questions, go ahead and shoot those on over through the questions tab, and we will answer as we go. Or if you want to hold your questions to the end, we'll make sure that we get those covered and answered for you. So with that said, I'm going to pass it over to Jeff.
All right, Lauren, thank you very much. Hi, everyone. Thanks again for joining today. As I know a lot of you have over the last few weeks, this is the fourth Wednesday wizardry training, and today we're talking about the production edition. And this is a great topic. I think it's something that not everybody knows a lot about. So I'm excited to explain this to you and help you understand the production capabilities of LED Wizard. So that's what we'll do today. This is the agenda, and so the production edition has really 5 elements, and this is what we'll focus on today. So the router layer, the auto mounting holes tool, the channel letter return plots, exporting to an automated bending machine like an AccuBend or a CLN bender, and then in a general sense, full-scale vector export. So those are the topics. As always, if you have any questions, please type them in there, and Lauren will interrupt me and ask the questions. If you've been on here before, you know that I just continue talking until I'm interrupted. So please, if something's not clear, go ahead and just interrupt with a question. So here's, as I start each week, I talk about what we're not talking about, and this is also a bit of an agenda. So we've done 3 webinars so far. The first one was power flow, and then side cabinets and cloud signs, and then data import and cleanup. And these are all recorded. To access these, if you haven't seen them, you just go to the link of the original webinar and pretend like you're signing up, and then you get access to the recording. So on the schedule, next week, next Wednesday, we're not doing a training. Instead, we're announcing our partnership with Crotech. And just as a little preview, this is a company that does RGB lighting with DMX technologies, among others. And they do some really amazing stuff. And we're working with them to bring some of those capabilities into the sign industry. So that's going to be really an exciting webinar. It's next Wednesday at the end. Lauren's going to give us some more information on that. So there are 3 new trainings that we added. The following week, May 6th, stats and title blocks. May 13th, power supply loading. And then May 20th, vectorizing, on-screen digitizing, and freehand drawing. So how to handle bitmaps as artwork. Okay, so that's kind of the schedule, a little bit where we've been, where we're going. I did want to just introduce the production edition here, and I've put this little table back up as a reminder of the pricing. So the production edition is $19.95 a month per seat. If you're a large organization, you wouldn't need the production edition really on every seat. Maybe you would only have it on a few of the seats. But in general, the production edition is a production tool that helps you produce your jobs faster and more accurately. Okay, it ties together the estimating and the production workflows in a shop, and I think that the main overall point here is that LED Wizard is often thought of as a layout tool, as an estimating tool, right? But there's a lot more to it as a production tool, and that's what we're focusing on today. How do you take that layout that you use to estimate, and how do you carry that through your shop to help you actually produce the job? So it's a set of capabilities to create and export full-scale production files, usually as a DXF file, that goes out to your router, that goes out to your vendor. Okay, so that's what we're talking about today. So I won't be doing, other than maybe a couple of quick layouts just to set up some letters. It's not as much about the LED layout part. We're sort of assuming that that's done, and now we're carrying that through to the shop. I also wanted to bring back this this graphic here, which I haven't done each week, but I just wanted to mention here that, you know, this is firmly in the LED Wizard 8 category, right? These production features. Our internal team, you know, can provide you with maybe a router layer file. We do that for some customers. But I think in the context of your workflow in your shop, the equipment that you have, the software that you have, you know, using LED Wizard 8 to create all this stuff makes a lot more sense. And certainly this is not the kind of thing we do in the online version, right? There's no production, you know, capabilities in the online version. So again, LED Wizard 8 is what we're talking about today. Okay, so let's get into it. The first, and I'd say the main, most important capability of the production edition is what we call the router layer. And, you know, at its essence, the router layer is a layer of data that indicates the position of each LED. Okay, and again, to back up to a higher level about this, you know, the goal of what we're doing, especially with this feature, is making sure that when you produce your job, that you're producing it in a consistent way with how it was laid out and how it was estimated. Okay, so, you know, the production edition is about making sure that there's a linkage really between sales and production. And, you know, in a big shop, there's different departments, there's different folks. As a job moves through the shop, it's easy for changes to be made. It's easy for people, you know, downstream to make decisions that are different from how the job was estimated. And if you're not careful about maintaining consistency, you can produce a job in a very different way from how it was estimated, and then perhaps you're losing money instead of making money on that job, right? Maybe some guys in the shop are making decisions about the job on the fly, right? That weren't planned or that weren't built into to the job. So that's kind of what we're doing here. So the router layer is it's exported as a DXF, and the idea is that you etch or mark directly on the letterbacks. Okay, the position of each LED. All right. So two main points about this. Number one, it maintains accuracy, as I said. But number two, you know, it really improves the productivity, right, of the folks in the shop putting down LEDs. So you don't have to interpret a layout. You don't even have to measure, for that matter. You just put the LED where the mark is. Excuse me. So, so it's a huge productivity benefit. Now, depending on your equipment, when I say mark or etch or score, this could be just a Z depth on your router bit. It could be a pen on your router. I've heard of people laser cutting at a low power, you know, the marks. I've seen for cabinets, I've seen shops plot out a pattern. Let's say that it's, you know, you're mounting on acrylic, you put that pattern right under the acrylic, you see right through it, you see where the modules go. So there's a lot of different ways that you can utilize this. And again, some of it depends on your software, on your equipment, you know, and your workflow. Okay, so one of the ways that I suggest, you know, that this feature is utilized, and in general the production edition, is, you know, get the estimator and the production manager, or equivalent titles, equivalent folks, in the same room and agree on the layout up front, right? Give the production folks input to that layout when it's quoted, when the job is sold, so that everyone's on the same page, and that layout becomes like a movie script in essence, right? If there's questions about that job, how should it be done, you know, how is it being laid out, you know, that layout file, that printed document, that layout file sort of becomes a movie script. You go back to that and you say, well, what does the layout say? Because we've all agreed on the layout up front. Okay, so that's kind of how I think the router layer can be utilized. Specifically in the software, there are three options. And of course, I'll I'll show these here in a minute. So the first one, which actually was from the prior LED Wizard 7 version, separated lines. Okay, it's a top graphic here. It's a little line that's in the exact position, angle, and length of the module. Okay, and this is very precise, but it's a little bit slow, right? Because the router has to go up and down, right? And I don't think we appreciated that when we designed this up front, that that the up and down movement of a router is slow. So in many ways, this is, again, it's visually, I think it's the most accurate, but from a productivity standpoint, it's just not as fast. So we continued on in LED Wizard 8 with the second two options, which is a continuous path. Okay, so the continuous path here, I say here, is basically the vector guide path, right? It's the underlying path that defines where the LEDs go. Okay, it's fast, it's smooth, right? But in this case, it doesn't indicate the exact position of each LED. So the middle graphic, it's just a vector path. Okay. Now that can be useful if you're doing, like these little acrylic letters where you have, mini LEDs or a tape or something like that, and you're mounting that in the back of the letter, right? You can just route out that path or that groove and mount LEDs in there, and this works perfect for that. But the bottom graphic, the bottom option, is perhaps the best, I think, is it's a continuous path with notches. Okay, so it might be hard to see in that graphic, but there's little notches there, and you can define the height of those notches, the length of those notches. I'll show you that. So this kind of has benefits of both, where it's a continuous path where the router doesn't have to lift up, but it indicates the position of each LED with one of these little notches. Okay, so that really is, perhaps the best option that combines the two. So that's kind of how the router layer is generated. And then when you go to export, so here, this is a snippet of the export dialog box. So normally this is a full-scale DXF. It could be an AI or an EPS, but most machines take a DXF. This is layer 1, is the original vector graphic, the original design file, original lettering, and then the layer is called module markings. Okay, that's the actual layer that you select. So as always in the export dialog box, you can click on the preview button, and that will show you just to confirm. I know there's some other layers in here. We're not talking about Flex today, but that's in development. But it's the module markings layer, and I've set up an export profile called production, and I'm going to use that for a couple of the examples today. It has the router layer, module markings, mounting holes that we'll talk about in a second, and layer 1. Okay, so in router vernacular, this might be your first pass, different Z depth, probably is the first thing you do. Maybe secondly, you drill holes. Third, you route out the backs. Okay, that's the router layer as an intro, and I'll go through that examples here in a minute. So let's move on to auto mounting holes tool. If there's no questions, Lauren.
No questions, you're good to go.
Okay, terrific. So auto mounting holes tool, this is the second feature in the production edition. And this is a terrific tool that we developed in conjunction with some large shops who, were tired of the process of creating mounting holes by, copying and pasting these little holes all day long. And I make jokes about this in reference to this tool, but that's pretty much what shops do. You draw a little 1/4-inch hole, and you duplicate it across, and you put it where it needs to be. What this tool does is, basically creates guidelines that go across your letter set or across your cabinet. And every time there's an intersection on a stroke, it will place 1, 2, 3, or more mounting holes, and those will be positioned by the guideline and then by the inline, right? So I've got a little inline coming off the return here, and I'll show you this in a minute. So that's kind of how it works. And so the holes are positioned there, and you have a property bar that has a lot of options. There's a lot of different ways that you can sort of go through and manage this tool. The basic workflow here, you have your graphic. The first thing is the horizontal guidelines go across. You can create and select the size of your holes. You can set the inline or an offset. We use these terms interchangeably. From the return, so how far from the return am I coming off? The number of guidelines. You can name the layers. So the mounting holes and the optional crosshairs. So if you, in your shop, if you just drill holes, then you can just put a crosshair, as opposed to if you route the holes, you would put it in the little circle. So you can name those, and then when you export, you can select different layers that you want to export. So you select the number or position of the holes in the stroke, and then you click on Add Holes. So everything in this tool is in preview mode prior to actually committing and putting the holes in there. And then if you want a set of different sized holes, then you would just run the tool again. You'd run the tool a second time, and maybe this is wiring holes, right? So you can run the tool multiple times, but it's a one size hole for each time that you run through. Okay, and I think most of the time this is used for channel letters, but I also want to just give an example here for cabinet. And the tool has what's called even distribution mode, and you set basically a maximum value that you want to have as the maximum distance between your holes. Okay, so I think I have my example, here, 18 inches. So if you have a cabinet or a really big letter, like a Z, for example, and you need to put more than 3 holes, 1, 2, or 3 holes is really the default. But if you want to add more holes, you turn on this tool, and it will evenly space the holes, not to exceed, in this case, 18 inches, right? It may be 16 inches, but it won't be more than 18 inches. So this is a good tool for cabinets as well. I mentioned here at the bottom, you can save common cabinet layouts with holes in the object library. If you're not familiar with the object library, that's a little tool where you can save things to it that you commonly use in jobs, and then easily click and drag those in. So as an example, maybe they're real basic size cabinets that already have mounting holes or something. Okay, so that's mounting holes, and again, I'll spend more time on the software here in a minute. So channel letter return plots is the next item here, and this is actually a capability that we've had in our software, area software, Sign Wizard and Neon Wizard for years, and it's a really terrific tool. I always say it's the next best thing to an automated channel letter bending machine, right? It's a step up from doing this manually, but it's not quite like a machine. Right? It's not as automated as a machine. But what this tool does is it creates a pattern. We call it a return pattern. And you plot this pattern out, and you slice each pattern for each return. You tape it up to the return, and it shows you where to bend, where to cut. Well, the length of the pattern is the exact length of the return. So it shows you where to bend. It shows you, is it a radius bend? Is it a hard bend? Is it a normal or a reverse style bend? And it tells you, on a hard bend, it tells you the angle. And on an angled bend or a soft bend, it'll give you a radius. So based on that radius, that can help you determine which notching tool to use for the flange. Okay, so you can again, depending on your equipment, depending on how you do this, that'll help you to correctly notch. And really, there's a couple of inputs that go into this tool. There's the thickness of your return material. So we create an offset for that. And the point of this is this return pattern needs to go on the outside of the letters. It's designed to go on the outside of the letter backs. Okay, so we ask for this thickness so that we offset so that we don't come up short, essentially, as we go around the outside. And we also ask for your tool diameter because a router bit is going to radius an inside corner, right? So we want to make sure that our pattern has that same little radius. So we ask for your tool diameter. If you're using a laser, for example, then you would say 0, right? There's no offset with the laser, so that wouldn't be an issue. So that's kind of the first step, is to identify those two settings. And there are a few other settings that I'll talk through when I do this, but this is kind of what it looks like. So my letter was CLR, and I ended up with 4 patterns because the internal loops get their own pattern, because that's a separate return. So so the length of this pattern is exactly the length of the perimeter of the letter, plus any overlap, which is one of the inputs. So if you want to have that return overlap by, say, 1/2 inch, so you can clinch it, you would just add 1/2 inch to this pattern. So the way this works is you also have an opportunity to set the start point for the loop, and it's kind of too small to really see where I did that here, but you set the start point, so that start point becomes the start of the pattern. And as you go this way, you're going around the loop clockwise or counterclockwise for an internal. And then each one of these lines or dash lines indicates what you should do at that point. Okay, a solid line, sharp bend in normal direction, right? Short dashed line, an opposite bend, okay? Normal bend here, opposite bend here. Long dashed line is a smooth transition. That's that would be on an R, right? Most of these points on the C. It could be a transition between a line and an arc, but it's a smooth transition. And again, you can't see it real well, but the hard bends have an angle that is positioned vertically next to the line, and then the radius has an angle. And so these values here are the angle of that radius. Again, that's what helps determine which notching tool to use. So let me go back. So again, this tool is an intermediate step in bending, does provide some automation. And even if you're a shop that has an automatic bending machine or more than one, it's never a bad idea to have a fallback position in case that machine's down. And this would be a good thing to just kind of have in your back pocket in that case.
Jeff,
yeah.
We do have one question.
Sure.
Will the offset also accommodate minus numbers, such as for reverse letters?
Yeah, that's a good question. So the tool was designed to go around the letter backs. Now the way, if you had a halo lit letter and you wanted this pattern to bend and mount behind the face, you can do that, but you have to kind of, it's a little bit of a hack to do that. So so the tool doesn't take a negative value for an offset, but you can negatively offset the letters before you run the tool and essentially achieve the same thing. So it's a little bit backwards the way to do it, but you can do that so that the return isn't on the outside of the face, so it's behind the face. So you would negatively offset the letters by the return amount. By the material thickness, say 0.04, and then you would run the tool with a 0 offset, and that would take care of it. So sometimes this tool has a little bit of, depending on your equipment and stuff and the way you're doing, a little bit of testing, I certainly suggest testing with with one letter first. But yeah, it's a great question. Okay, so and I'll talk about that when I get into this. Just real quick now, a couple other things. Exporting to your channel letter bender. Okay, so notwithstanding anything that I just said, the software can still export a DXF file that goes to your bender. And remember that a DXF file is arcs and lines. Okay, so if you have all chords, which would be this center example here, or more commonly, if you have artwork that has Bezier curves, okay, which will be essentially what you'll get out of Illustrator or Corel. A lot of applications create Bezier curves, and Bezier curves are great, right? Because they can define a complex shape in a minimum number of nodes, but your router doesn't know about Bezier curves. Okay, so you have to convert from Bezier curves to lines and arcs. Okay, and I talked about this, was it last week? We talked about optimized vectors, we talked about alt smoothing. So these are tools to convert artwork, clean up artwork, and this sort of thing. And for this task, that's important. Okay, the machine, whichever machine that you have, will be expecting artwork that looks something like the bottom. It doesn't want artwork that looks like the top example or the middle example, right? So, we've worked with the folks from AccuBend and CLN of South Florida for decades for the AccuBend folks. We go back with them, both of them really, for a lot of years. And what they want is data that looks like the bottom. Okay, so if you have, and they have software that helps in this, but it's always better to give them a file that's already clean the way that they're expecting, so that they don't have to do anything else with it. If you have too few arcs, then they can sort of get lost along the way, right? That's not really enough data points for their purpose. If you have too many points, then the machine kind of chokes on that. It says, there's just not enough of a change point to point. I don't really know where to go. Am I going around an arc? Is it a straight line? Each point is too close to the next one, in which case they end up skipping points. And anyway, so what you want is the bottom example, and you want arcs that are, say, 30 to 45 degrees. And the CLN folks, I think, give the best analogy, which is, think of the hands of a clock. Okay, there's 12 hands on a clock, so you have 12 30-degree arcs in a circle. Okay, that's a great analogy, and that's looks like more or less that's what this example shows. Okay, that's a good number of points to think about. So we did talk about this a little bit last week. I'm not sure if I'll have time to do this again today, but optimize vectors, as a first tool to run when you import something, and then alt smoothing in a more manual way to go in and clean up points. Okay, so this is the final, I think the final slide before I get into this, and this is just, in a general sense, the production edition will export a full-scale vector file. The regular edition of LED Wizard 8 only exports a scaled PDF. Okay, so and I've talked about these things already. I think that the only additional option here is, well, what if I just use a software to create the art for my faces and my backs, right? And if you want to do that, that's great. You can offset. We have an offset feature. You'd probably do that in your router software, but there may be other uses for the full scale file. And I think one of the important things to think about, if you're considering using LED Wizard for more of your production files, just make sure that you're dealing with consistent artwork, with consistent files from the beginning. Once you start offsetting and once you start doing different things, if you're cleaning up artwork, you start to create perhaps versions that are different and this kind of thing. So especially if you're using LED Wizard for some things and you're using, FlexiSign for something else, just make sure that artwork doesn't change and things don't change. Okay, so that is, let me go into the software. So any questions? I'll just pause real quick, Lauren.
No questions right now.
Okay, so I am going to type in here, and I'm going to type in some channel letters. And this is, what did I do? 48-inch avant-garde Gothic bold. This is a Sign Wizard font, so I know that it's a good clean font. I'm gonna go into PowerFlow, and I'm just gonna do a single run layout, and this will be my layout for creating a couple examples. I'm gonna do Patriot Medium, our new Patriot 24-volt module. So let's do that. It's just gonna be a single run layout. I'm doing 4-inch depth. We have a stroke of about 12 inches on these letters. Okay, so the first thing I'll do, so I'm not going through to the template. I'm not creating the stats and all that. I'm just going to use this as my file for first for the router layer. Okay, so I'm not going to go in and edit or clean this up. It looks pretty good. I would consider doing maybe a couple things here, but I'm not gonna, that's not the topic for today. So here's my layout. I'm gonna go to the LED menu, create router layer. And this dialog is where I choose one of the three options that I talked about before. So the continuous path, unchecking that. And that just means that I'm just gonna create the lines in this case, okay? And so these are the lines. That's very simple, right? These lines, if I go back and zoom in, you can't even really see them. They're just in the exact position here. So if I move that off, that's what the router layer looks like as individual lines. Now, if I go over here into my layers tab, and I don't know how many use the layers tab, but this is a place where I can see I can see different layers of data, right? So down here at the bottom, module markings. This is the name of the layer that comes in, and when I export, I would be able to select or deselect that layer, and I'll do that here in a second. Okay, so pretty simple. That's the first option, and I will also say that this is really the last thing that you want to do. Okay, so if you're creating a router layer, you certainly don't want to, change module position or do anything else. It's really one of the last things that I like to do at the end. Okay, so let's go ahead and go back in, bring this up a little bit, and I'll run the tool again. And this time, I want to select continuous path, but no notches. This is going to be the second option that I talked about before, just a basic continuous path. Okay, that's what the path looks. It's very clean. Again, had I edited, maybe I would clean up that corner and this kind of thing, but basically that's it. So, it's going to go to the end of the modules. It doesn't, perfectly approximate the stroke in all cases. It's the actual path of the LEDs. Okay, so maybe this is a little bit shorter than this, and that's just because that's where the end of the module was. So again, pretty clean, just a straight, export of a nice and smooth path. Now the third option has the notches, and these notches, I have 0.248 inches for some reason as my notch, my notch length, and module mark length. So that's 1 inch. So that's the sort of the straight line that goes with each notch. show you that. So this is what the notch pattern looks like. Okay, so every time there's that little notch, you know, that's where the LED goes. And you can't really see here. But this is the 1 inch. This is the line. This is what the vector data actually looks like. So that is, even though this is a curve, that's essentially a straight line, and then that's a value that you can play with. So if I change the notch could be bigger or smaller. You know, it doesn't need to be very big. You just need to be able to see it. Okay, so that is the pattern with the notches. So let me just I'm going to group these two back together. And remember that when you export, you can export just a selection of, you know, I don't have to export the entire layout. So I'm just going to select this and then do export. And what I see here is my my layers to export. Okay. And in this, you know, normally if I was exporting as an estimate a PDF, I'd include, you know, all layers or most layers. But in this case, I'm going to select an export profile preset that I made, an export profile called production. And there's only 2 layers that I want here. I want layer 1, which is the original outline vector data, and module markings. So now that I have that selected, I'm going to click on preview. And again, we have these extra flex items there. You can ignore those for now. That is what my file looks like. Let's just call this CL. So I'm going to export that. And before I do that, there is a little dialog box here. If you click on options for DXF, if you know about DXF, you know that there's a lot of flavors of it, I like to say. And it's you know, we like polylines, lines and arcs. You can do inches or millimeters, which is you know, a setting here. Polyline lines only, separated arcs and lines exploded. Generally, we only use that actually when you're exporting to an AccuBend. That is the setting to use. But normally, polyline lines and arcs and inches. So I exported that. I'm just going to import that back in. Okay, and that's what it looks like. Again, there's no offset here, right? If you're doing something with those letters, there's no offset, but you could do that. You know, we have in tools, we have our outline, which is offset, could be negative or positive. But that's what that file looks like. So that's the top example. Obviously, the other examples would just have, you know, the other way to do the router layer. Okay, so that's you know, that's it for the router layer, right? It's not any more complicated than that. The hard work on the router layer is done in making the layout, right? Getting everything into the right spot. Once you have that, doing this final step, there's not a whole lot to do. Just make sure you have the right thing selected and the right layers. Okay, so let's move on. And I want to talk about the auto mounting holes tool now. And I'm going to use the same example. I think that this has, yeah, it has the notches layer under there, which is fine. So here's how the auto mounting holes tool works. You want to select, again, the artwork that you're going to work with. And definitely in this case, you want to have the LEDs in there first. Don't run the mounting holes tool first and then use that to populate, because you'll have all these circles in there that'll mess up our path. And you know, and you want to know where the LEDs are to figure out where the holes should be. So LED auto mounting holes tool, and essentially what this does, as I mentioned, the first real option I think is to figure out how many of these horizontal guides that you want. Okay, and that's this drop down right here. So these are 48-inch letters. I'm going to say 3. You know, maybe you could do it in 2. So it puts the paths here, and then the guidelines, and I can drag them to exactly where I want them. but don't drag it outside of the offset amount, because then that'll get cleared out. So you know, it could be right on the offset line. I usually do it just a little bit inside of the offset line. Keep in mind that rounded, you know, if I put it too high on the rounded, I'm going to be outside of the range for the square letters. So I want to do something like that. Okay. Now, the second option, I suppose, could be what's the inline amount, right? How far off am I coming from? Let me click on preview. So every time you make a change in this tool, you have to click on preview. You're always in a preview mode, essentially. So this inline amount I have at 1 inch. This is a pretty big letter. Let's say I do 1.5, click on preview. So yeah, that inline came in a little bit, and I'm just barely inside there, so I guess that's still okay. So that's my inline amount. And then next would be deciding on the size of your hole. Okay, so I have presets here, and I can add hole sizes, and it's easy to do. You just put it in here and then click on the plus button. But I have a quarter. Let's say I'll do 3/8. Click on preview. So that's a 3/8 hole. Okay. Past that, you then decide, okay, how many mounting holes do I want across a given stroke? All right. So the way that this works is every time that there's an intersection across a stroke, it's going to put 1, 2, 3 or more holes. And let's just focus on this H for now. So these 3 icons here determine how many holes and where they are. Okay, so if I select all 3 of those, I now have 3 mounting holes across this stroke. Probably overkill. Okay, if I take out the middle one, I have right and left. Let's say that's what I want to do. So the H actually takes you know, 10 mounting holes in this case, 2 here in the middle, 4 each on the top and the bottom. The A, same number actually. So every time that there's an intersection, it's you know, it's going to put those holes. All right, and it's easy to change this. Right, smaller letters, you might just do 1. You know, sometimes if the LEDs are in the middle, you want to put the mounting hole on the side. This is completely up to you about how you want to do it. Now, if you have a very large set of letters or a cabinet, and I mentioned that we have this idea of the horizontal spacing. Okay, so if I want to make sure on a very big letter that I have enough holes, then I would select maximum horizontal spacing, let's say 18, and I would click on this option right here. Okay, even distribution mode. Now, when I do that, even though in this design I have just 2 holes selected, now I have 3 holes that came in on this, because this distance would have been greater than 18 inches from one hole to the next. If I change this and I say, okay, let's do 12, didn't make any difference. I still, in this case, ended up with 3 holes. So let's bring this down. 8 inches. Okay, mounting holes every 8 inches. So now I've got 4 across the bottom there. All right. I don't have to do that in this case, so I'll just turn that off. But that's again, that's how you can do a very big letter or a cabinet. Okay, so I also mentioned crosshairs, and crosshairs are an option. So again, the feedback was, hey, we just drill the holes, right? We just put a crosshair there and manually drill it. So the optional crosshair, and that is on its own layer. So you can either put the holes, the crosshairs, or both. And in fact, these are the names of the layers. So you can name the holes and crosshair layers whatever you want to. I don't see that happen very often. Holes and crosshairs seems descriptive enough to me, but if you want to change the name, you can. So that's the essence of it. So again, I'm always in preview mode until I click add holes, and then it actually finishes the tool and puts those holes in. Okay, so that's what it looks like. Now, if you change your mind and you say, gee, I don't really need this guy here, you can just delete it, right? It's just a vector object. if after the fact, by the same token, you say, hey, I want to add another hole here, the vector object, I did D for duplicate, right? So you can do that. You can slide along the guide path. So it's automated, but at the end of the day, we're just creating vector objects here. So if you need to adjust or do some copying and pasting, you certainly can. Within the tool, there are options too to move things around, delete, and that sort of thing. Now, if you wanted to go back and do this, I'm not going to do this in the interest of time, but you can go back in the tool, run it again, and pick a different hole size, right? So if the next pass you want wiring holes, you'd select whatever, a 1/2 inch hole. Wiring holes are a little bit more tricky because they're going to be in different positions in the letter. So it's not quite as automated as mounting holes. And the tool wasn't really designed per se for wiring holes, but certainly you can create, 1 hole per letter, and you can move that hole and put it where you need to. Some cases it comes out real clean, right? If you're on a raceway, you can put the wiring holes all within the range or on a guideline that's the center of that raceway, and that's a pretty clean way to do it. So that would be an option as well. Okay, so so that's the auto mounting holes tool. Let's see, I wanted to do, if there are any questions, I'm going to do a quick return pattern.
No questions, you're good.
Okay, thanks, Lauren. Let me just make sure that I can have time to get this finished. So let's make this a 36-inch letter, and this is actually, I don't need an LED layout in order to do this. In fact, I would, if I was making a return pattern, I would just take the original artwork, make sure again that everything's consistent, and I'd go in here into channel letter return. And I think the last time I did this, I was in metric mode. So let me change my values. So offset, I mentioned offset and tool diameter are the two things that that you want to enter as the first step in this tool. So this is a little sort of floating dialog box here that defines the interface for this tool. So the first thing I do is I'm putting in my return thickness and my tool diameter. Okay, then I click on the button that says create offset. Okay, so I've now created an offset. If you look close, I've got a little radius on that inside corner, right? It's going to be the same thing here. And again, because that's what my router does. That's what the, so we want to make sure that that's consistent. Now, these black boxes are the start endpoints. So I mentioned that each pattern has a start endpoint. Okay, and you have the opportunity here to position these wherever you want. Now, I like them on the top. I like them on a straight line if possible. You can put them on a corner. You can put them anywhere. Internals, maybe you'd have some other way to do those. You certainly need to make sure that you have the correct loop directions because these are directional, outside clockwise, inside counterclockwise. Okay, so on the R, our pattern starts here, goes this way, and goes around that arc first. Okay, once you have those set, then there are 4 additional options. And again, I apologize for the funny sizes here. So I'm going to do 3 inches for the tape width, and that is just anything that's really less than the depth of the letter, right? Anything smaller than the return, because this actual pattern you'll put up to your return. Material width, this is actually the plottable size of your plotter. Okay, so the assumption is that you're plotting these patterns. Some of these patterns can get very long, so you have to make sure you have good tracking on your plotter. Some customers will also print these. Some will print on vinyl, which is expensive, but that's an option too. So material width, because these are nested. Gap is just between each pattern. We could do 1 inch. I mentioned overlap. So let's do overlap of 1/2 inch. So the return will overlap by 1/2 inch, so you can clinch it. Okay, those are the 4 inputs. And when I click on OK, then it makes the patterns. Okay, so these are the actual patterns, and I have 8 patterns because I have 2 internals. And I was going to look at the R first, so let's just zoom in. So this is the initial. We put a little graphic at the beginning to kind of get, so you can get your bearings here. So the end of this pattern is this start point here. Okay, and we're going clockwise around, and this first mark here, we used to call it maybe a tick mark, is the beginning of this radius here. Actually, sorry, this is the beginning, a very slight radius here at the beginning.
Jeff,
Yeah.
what happens if you don't enter the tool diameter? Will it do a hard corner with no radius?
Correct. Okay. That's correct. Yeah, if you have a laser, or I don't know if like a plasma or a water jet can be that precise, I think it is, you can put 0 for the tool diameter. Yeah, exactly. So this R will, this pattern will continue. 12 inches is my radius on that, and here's my my little inside corner there that is that has that little radius, and then we get down, and most of these are straight lines. So if I look to the end, so again, here's a straight line, right? That's a hard bend, 89 degrees, 90 degrees. And then this little bit here at the end, this is my 1/2 inch overlap. Even though it just shows a line to indicate that that's the overlap amount. So if I click on this R pattern, okay, this is 145.7687 inches. And if I went in and looked at the total perimeter here of the R, it would be the exact value minus 1/2 inch. Okay. So essentially that's how this works. Okay, you plot this out, you strip down the returns, you tape them, paste them up to the returns, and it tells you exactly where to bend. Now, one thing that is important here, similar to exporting to an automatic bending machine, is you do want this artwork to be clean, right? I've seen some of these patterns where you know, someone didn't really clean this up, and there's a million points along these arcs, and it becomes not very useful, right? In that case, some customers will prioritize the hard bends, and they'll do the hard bends first as the most critical, and then you know, use the softer bends as a guideline. You know, I mean, you're going to have the back right there in front of you, right? So maybe the hard bends are you know, are the most critical. So I think it's something that you know, try it out on a letter, you know, test it out on a you know, an 18-inch R, capital R, something like that, to sort of get your feet wet on it. The internal loop here, okay, counterclockwise loop. Otherwise, everything's the same. It just goes the opposite direction. Okay. This will also work for metric. There's nothing about this that doesn't also work for metric. I think the biggest challenge that I've seen with this is, in some cases, the sheer size and the sheer length of these returns. We don't have an automatic way to cut this down to a certain size. A customer might say, well, I've got a 10-foot break and I need to stay within that. So if that's the case, you basically just have to break these. You can vector edit and just break the loop open. Just do it on the top and bottom. You have to break into loops. It's not difficult, but it's a little bit more manual. In which case you could then deal with these things in more manageable chunks, and then you can put them back together after the fact. So again, you know, you look at this letter N. What did I do? A 36-inch letter. You know, I've got 191 inches, right, of a pattern. So that's pretty far for your plotter. So that's really the main gotcha that I've seen. But you know, we used to promote and advertise this feature as you know, throw away your tape measure, right? You don't really need the measuring. The measuring is all done here for you. Okay, so that's about as much as I think I can do in the time we have. And of course, the last couple items were just exporting to a DXF, and you know, some of the vector cleanup tools and those features, some of which I talked about last week, you know, would apply here, right? So you know, anything that you export to a DXF for production should be, you know, should be a cleaned up file. You know, I've been focusing on DXF as the format, but again, in reference to last week, as we talked about artwork, there are additional formats that you can use, AI or EPS, you know, probably being two of the primary ones. And I'll just finish, unless there's any more questions, just with the logical extension of this, which is, you know, in your shop, what other software programs do you use? And do you need to use them, right? So, you know, some customers will create a layout and then export that whole layout into another program and do some of the same things that I've just showed you. So maybe you don't have to do that, right? Maybe you just go from LED Wizard straight to your router. So it's something to consider. By the same token, the topic we discussed last week of importing, you know, maybe you don't need to import into Illustrator first or FlexiSign first. Maybe you come straight into LED Wizard with your artwork. So there's an opportunity on the front end and the back end here to perhaps, you know, clean up your workflow a little bit and do a little bit more in LED Wizard. So that I'll just leave you with that idea. So so Lauren, again, any questions? I feel like it's a usual. I'm talking as fast as I can to cover all of the topics, but you know, there's a lot here on the production edition. So hopefully this has been helpful for everyone.
Yeah, that was great, Jeff. We did just have one last question come in. Can you save any templates for raceway holes?
Sure. Yeah, I mean, let me real fast here. So if I had a let's say that this was my standard cabinet size. Well, actually, you said raceway. Okay, so let's say that this is a standard raceway that I might use. I'm making the height 12 inches, let's say 12 by 120. Okay, that's my raceway. If I wanted to run the mounting holes tool on this in the same way that I did previously, let's see. You know, because I extended this, I kind of messed up the spacing here a little bit. But let's say that I wanted 18 inches as my max spacing. Okay, and I've created this, and I want just two. Let's just do top and bottom. Okay, something like this. So if this was my, oops, group this together. If this was my raceway, and I wanted to save that, so I mentioned the object library, right? Oops. I could go, forgot I couldn't click and drag. So I could go to the plus sign on the object library, and I could call this, you know, raceway 1. Okay, now it's saved in here. So on a future job, if I wanted to insert this raceway, I just drag it in from the object library. Okay, so that's a 1-minute pitch for the object library. So it's very easy to create something, save it out to that object library, and then you would have this to you know, to bring back in. You know, I don't even know what these things are. Here's a some kind of a circle layout. So, you know, actually within Principal, we use the object library extensively for different products. You can do text, you can do graphics, all kinds of stuff. So if you have a standard set of raceways and you want to bring that in and it's got holes already in there, I would do it in the object library for sure.
Great. That's all the questions we have right now, Jeff.
All right, terrific. Okay, well, thanks everyone again for joining. I hope everyone is staying safe and staying healthy. we're all hopeful that things will get moving here again. But certainly I appreciate that you guys are taking your time to learn more about LED Wizard, and we'll see you in 2 weeks with our next webinar. Thanks, everyone.